Hello, I'm Stephanie Zhu.
Hi, I'm Punit Pandit.
And I'm Seong Heon Kim.
And we are the SPS engineers. This is our solar survey project for Engineering 6. Enjoy.
In the solar survey project, we use the Arduino solar cell in conjunction with MATLAB to gather data. We gather two types of data, one where we set the hardware to have a closed circuit variable resistance and the other with an open circuit constant resistance. Our team selected a region to survey by taking data to fully cover the area, which is the city of Davis. Afterwards, we manipulated this data to create a solar profile of the area surveyed. We split up the region of Davis into 3 parts, so all of us had an equal and spacious amount to work with to do the survey. We made 2 GUIs to help us with this project, one to collect the data and store it, and the other to plot the data for analysis. We collected the data at different times, and at each time we had 10 trials. The objective of the project was to learn how to use the Arduino hardware and manipulate MATLAB functions to exert a sufficient code that enables the user to examine the amount of light in a particular area. This project correlated to Lab Quiz 7, where we had to use a code to run the Arduino hardware to calculate the amount of light hitting it at different angles and at different environments of light.
I'll take you to the first part of our GUI, which is gathering the data and measuring the voltage from the sunlight hitting our solar cell. So first, make sure you have Arduino M in the same folder you're running the whole thing, because the file calls up the Arduino object, and without it you can't run it. We also have some additional data sets here. These 3 are for storing the data that we collect. This is for the GUI internally to run. Alright, GUI looks like this. You would type in the port number here. You would select the location by clicking location. You click on a map. This works, I'll show you in the code. It works kind of like task 25 or 26 in the first project. You can also select, what are you doing? Okay. Alright, you can also select whatever time here, and then you would click to start this, you would set the settings, and then it would start the load sweep. The way our GUI works is it alternates between load sweep and open circuit sweep. So I'll show you inside the M file. So first, go down. Alright. So first we have location set, where we set our location. We would load Davis sectors, that's one of our map files, that contains the data, the coordinates, to make polygons for each of the areas that we surveyed. By using in-polygon, as you can see over here, we can find out wherever the user is selecting as their location. It's within a while loop, so the while loop ensures that that you select a place inside the area. If you don't select the place inside the map, the while loop won't end until you do. So as you can see, if you set it, it'll set to 0 and it'll delete the while loop. Alright, and once you set the area, it calls up a cell structure that contains each of the locations. Each of the locations are labeled 1 through 15, spelled out, not numbers, but like O-N-E, like for 1, and then so on and so forth for till 15, because we have 15 locations. And that would be set as a variable called area. And we use that variable later to call back our structures for saving our data. Then we save area so we can use it later in a function. Moving down, this is for the time of day, executes on selection change in time of day. That's the pop-up menu. When that happens, we get the string from the object, and that includes every single option. So that's select time, morning, noon, evening, and to differentiate for that, we would also get the value from that time of day object. And depending on what value it is, we can call back, because we stored this into a cell, all the strings, and then we'd call back the contents of that one cell. Then we would save it so we can use it later. Now, this is where the data, where we gather the data first off. We named our button the tag settings. So first, once you press it, we would load up time, area, and the structures necessary for storing the data. We would acquire the port number. We get it from port num handles. That's the editable text box that we have. Where is it? There you go. You can edit that, type in whatever column number. Alright, and then after that, it would save it so you can use it later, because we have two buttons and they're two different functions. Secondly, we disable the buttons so you can't mess with them while it's running. Thirdly, we run it. We have something called count that keeps count of the trials that we're running. We would call it the Arduino object, set up the one of the resistors, and then we would make a cell first to store the data for quicker storage. Now we have it in a for loop for the load sweep. So for v equals to 0 to 255, that's the resistances that we sweep them through. We would have the Arduino running here. We would write the resistance, pause, read the voltage from the solar cell. We would store it after calculating using the formula from Lab 7, and it would loop and loop until it's done. And then we, in order to save space, we didn't type out each and every one of the, like, if area equals to 1. No, we stored area, and then we used a function called genVarName. So it generates a variable name using a variable. So if you had a variable with a string, it would use that string as a variable name. So we don't have to know the contents of the string in order to have another variable name. So we use eval, which evaluates a string as an expression. Sprintf time. Time is sprintf time. Time will call back whatever time of day, so that would be like morning, noon, or evening. In the string dot genVarName, so we click, like, you could click whatever location. Let's say you clicked location 8, it would display 8.date. It would store the date you collected the data. Here it would be sprintf time, which is, let's say, noon dot genVarName 8 dot load, and this would be a cell. All the data would be stored in a cell. So there would be, in these cells, there would be 10 matrices. 10 1 by 256 matrices? Yeah, 256 matrices, yeah. So then you would delete the Arduino object, we would save all the necessary data for later, and then we would enable the buttons to be pushed again, and we have something that will show you that, oh, the trials are finished. Now we have a second button that will enable you to continue collecting data. It's because we didn't want to load everything onto one button. It would be rather confusing. So the second button would appear once you finish with the first button. You would load all the relevant information, add one to count to keep track of the trials. Now, since this one takes care of load sweep and open sweep, the way we did it was we alternated load and open sweep. So for the even number trials, that's open sweep, and for odd number trials, that's load sweep. So that's how we already differentiated them, by using rem count divided by 2, and if that wasn't 0, it would be an odd, so it would be load sweep, and the other one would be for open sweep. So with load sweep, we didn't change anything, we just used the way the load sweep worked on the first one. And else if it was even, if count was even, if count is less than 20, because we run it 20 times, because it's 10 trials per each type of data gathering. So this one, it would be a little bit different, because we would have, all the resistance would be constant, and yeah, we'll enable the buttons. And then else if, this is for when the final trial, count 20, nothing changes until the end, where we reset everything so you can use the GUI from the beginning again. And that's that.
Okay, so I'll take you through our second GUI, which is plotting the solar data. So first off, you will need to gather the data that you collected from the first GUI, which is the morning, noon, and the evening. After you have done that, you will need to create a GUI that allows the user to plot your data. So first off, you will need to set up a button group that has two radio buttons in it. One that says load sweep and the other one that says open sweep. The other one, you need a pop-up menu that allows the user to choose which time of the day that will let you plot it. So morning or noon or evening. And then after that, after you have done it, you need a push button that says plot. For our GUI, we created a static text that has the legends of each location that we collected the data. So I'll give you a run through of how our GUI looks like as we run this. We change the folder. I select load sweep, select the time, morning, and then boom, plot. So the x-axis represents the location of each of our data points. So 1 will be Arlington, 2 will be Shasta, 3 will be Sycamore, and so on. And red indicates that it's the highest intensity of the solar, and blue indicates the lowest intensity of the sun. So now I'll explain how our code is written. So first off, we need to go find the function where it allows us to execute on the selection change in date. So we go look for that, and it is right here. So first, this is how we will write our code. We will set a certain variable x is equal to cell string parentheses get handle object comma string, and then you get that variable x, and then you put it into another get handles object and into a value. Then you save that into two strings, and this will allow the user to choose the time of day on our GUI, such as for the morning, noon, or evening. And then afterwards, after we have done that, we will now go on head out to write our code when the user clicks on the button plot. So we find that, and here it is. So first we have to load up the variable x, which is that we created over here, that allows the user to choose the time of the day. And then we'll get another variable, set it get handles dot whatever sweep you wanted, open or load sweep. So my tag for load sweep was L sweep, comma string of value. Then you put it into a loop, which is if d is equal to 1. So that means that if it is a load sweep, if the user chooses the load sweep, then we'll use string compare of the x morning equal to 1. If the user chooses morning, we'll load morning. Then you set that equal to a variable into another variable. Then we'll do that for noon and evening. Then afterwards you end the function. Then we had to set a new variable so that we could create matrices of zeros from 1 to 15. And then we have to call our field names, which is the locations of on our GUI. So we'll set that into another variable, v is equal to field names p, that calls back the data for morning, noon, or evening, depending on which the user chooses. Then we have to make another loop that from n is equal to 1 to 15, which is the data point, and then you gotta make another variable that changes the cell structure of our data into a matrices, parentheses, p of whichever the user chooses, dot v of n dot load. After that, we have to take the zeros into the variable n so that we could find the maximum of our solar points. Then later, you end the loop. Then you have to lower the coordinates, which is f is equal to 1s of 516, 903. This is our the length of our Davis map, the x and y axis, then you have to make another variable that has zeros from 10 to 15. And then we'll have to make another variable that will concatenate our data so that we could make into a larger matrix, which is set into this code. After that, you have done that, you'll set into another loop. For is another variable, e from 1 to 15, and then you will have to do it like this so that we can set our plot. After you have done that, then you will have to use the function pcolor of our data points, which is known as, from the previous one, h times 255 data points because it was load sweep. Then after that, you will have to save that so that it will pop up. Your code will be the same exactly for the open sweep, but the only difference is that you, instead of calling it L sweep, you'll have to say dot open, which is this, and yeah, and that's the only thing that is different. And I hope this video has helped you understand our solar survey project. Please subscribe our YouTube channel, and I hope you could understand this. Thank you.